fill my water, so we'll be ready to go here in just a moment. And
Haystack Live. Thank you everyone for joining us. Today we've got a fantastic talk from James Rubinstein from LexisNexis. If you've been following all his excellent Medium posts, you'll be looking forward to this talk. As ever, we're recording this talk, so we'll put it out on Open Source Connections YouTube account later. A couple of other things. We've got some more of our training coming next week, learning to rank. There's still some tickets available for that. And then later in November, we're running our natural language search training, which we mentioned at the last meetup. So without further ado, I'm going to hand over to James. So if you have a question for James, do please put it in the Zoom chat, and I will then go through that after James has finished talking, and we can put your questions to James. So in the meantime, if you wouldn't mind muting your mic if you haven't already, in case of any background noise, but I shall now hand over with great thanks to James Rubinstein.
Thanks, Charlie. Yeah, thanks for the invite as well. I am certainly happy to be doing this, and just give me the opportunity to try to kind of condense a lot of my thoughts that I've had for the past few years into a single slide deck. So here goes. Let's see if we can make this work. All right, if you can just confirm that you can see that, I will get going here. Good?
Yep.
Cool. All right. Thanks, everyone. So yeah, my name's James Rubinstein. I work at LexisNexis. I am a data scientist here at LexisNexis and lead our product analytics team. But in previous lives, I've worked at some other companies that you may have heard of. I worked at eBay, Apple, and Pinterest previously. Kind of doing the same job there at each of those places, really running the human evaluation, search experimentation, those kind of things. And what was kind of interesting about that is that I actually had 3 different job titles at each company. So I was a product manager, a statistician, and then data scientist. So which just sort of indicates that people don't really know what to do or where to put people such as myself. And so it sort of got me thinking about like, what do these things actually mean? How do they all work together and so on? So it really had a lot of beneficial experiences, I suppose. So I wanted to kind of condense that and share that with you all to demonstrate how you could actually build your own search program, kind of brick by brick. So just getting started here. The next thing I'm going to say is actually the most important piece of the whole presentation. So hopefully you don't join late and miss it. Although if you do join late and miss it, you won't have heard me say that. So what is the most important piece of building a data-driven search program is to understand what your users are doing with your service and why. I think we spend a lot of time in search really thinking about quantitative methods and A/B testing and learning to rank and fancy machine learning and BERT and embeddings and blah, 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 right? All of these fun, fancy technologies and AI and machine learning and so on. But really the most important thing you can do in a search program is to actually understand why your users are using your service in the first place. I think it's very easy to make assumptions about what it is that your users are doing. They're searching for information. They want to get documents, whatever, right? If we were Google in, I don't know, 2000, and we made the assumption that users were looking for web pages, we never would have rolled out Google Images. We never would have rolled out the weather widget or the calculator widget or Gmail or any of those things, right? So a lot of the stuff that makes Google such a powerhouse in terms of information retrieval on the web has nothing to do with users looking for documents. And in fact, one of the areas where they probably do the poorest is a true document search, like for academic research, for instance. So we really have to be cognizant of what it is our users are actually doing, not what we think they're doing. And to do that, we have to use qualitative and quantitative methods like UX research, market research, investigating our logs, and watching people. So you can add in browser plugin, things like Telium and so on, and do some session recordings. And of course, you can watch people with permission in like UX research settings as well. So make sure that you're actually talking to your users, really understand what it is that they're doing and what their tasks are. That's going to really guide how you design and build your search program. So this is the second most important thing that I'm going to say in this presentation, and that is that search is like baseball. Search is all about the at-bats. It's all about taking as many chances as possible on the assumption that at some point you're going to get a hit. Search is not like golf. You don't get closer with every swing. That is, of course, assuming that you play golf better than I do, which is pretty terribly, and often I don't get closer with every swing, but let's just assume it's professional caliber baseball versus professional caliber golf here. So search is all about taking these chances. It's about taking as many swings of the bat as you can. But there are some ways that it is not just about randomly or blindly swinging. The better batter you are, the higher your batting average is, the better your chances, right? So if your batting average is 300, you're kind of by definition going to do better than somebody who has a batting average of 180 in terms of getting that hit. So what we're trying to do here is really improve our odds by being data-driven and by building a program around the data that we have to feed into our search program. And hopefully, if we improve our odds well enough, maybe we'll get some grand slams. So let's talk a little bit about the process. Step one, we're going to start with human evaluation. What is human evaluation? It's the process of getting people to evaluate content. I know, stunning, isn't it? What I mean by that is that we want to have people actually evaluate our search results, our inputs, or whatever, so that we can accurately measure things like relevance. So we'll talk about that in just a sec. So why do we want to use people to evaluate content? Machines are really good at evaluating content. We have all of these fancy machine learning things, as previously mentioned, but there are some things that computers are pretty bad at. For instance, if I ask a computer which of these is more appealing, you're going to have a very different approach. So you're going to see something really different than what you see here. So if I ask a human, do I like the tree or the pocket pies, I guess, what things are going to show up? People may like an individual person. Here we go. That's what I'm trying to say. An individual person may like the pies or maybe likes the tree better. But if I ask enough people, I'm going to get a pretty good idea of what it is that people in general like. And so this is the kind of thing that people are good at and machines are bad at. Human evaluation is also really important because it does something different than engagement metrics. So if I were to ask, and this is a real example, by the way, which of these images is more relevant to the query sweater, you would probably say the one on the right, right? For me anyway, I'm a human male. I would probably be more likely to wear a human male sweater rather than a dog sweater. So when I'm searching for sweater on Pinterest, this is something I'm a little bit more likely to engage with or more interested in, I guess I should say. However, if we look at the engagement overall, what we're likely to see is a lot more engagement with the cute puppy. So at Pinterest, I refer to this as the cute puppy problem. In other spaces, you might refer to this by other names, where you might see more engagement with things involving scantily clad young ladies. However, cute puppy problem is much more family friendly, so we're going with that. So the cute puppy problem is basically that people will engage with things even though they're not relevant, just because it's attention grabbing, it's salient. And so cute puppies tend to be very salient and attention grabbing for most people. Whereas the sweater is only salient and relevant to some subset of people. But if you know the subset of people are, then you can address that. Point being that sometimes you really need humans to do evaluation of things like relevance. Because it's such a squishy thing, you can't just rely on engagement to tell you about relevance.
So there's two main functions of human evaluation: steering and scoring. What I mean by that is steering would be like providing inputs. So maybe that's annotations, maybe that's categorization, maybe it's training data for a machine learned model. Maybe it's like looking up UPCs or SKUs, finding competitor prices, right? There's a whole bunch of different things that you can use human judgment and human evaluation for that machines can do okay at, but maybe aren't great. So this is an example of one from my friends at Crowdflower back in the day. That they did this task for a well-known solar company that was trying to get solar onto rooftops. And so one of the things that they wanted to do to target certain customers who were likely purchasers of the service or product is to figure out who actually has enough area of roof that is actually being hit by the sun. So basically they went and they asked the crowd, how much of this house is covered by trees? And basically, is it 10% to 25%, 25 to 75, more than 75, right? So just a really simple task. It's the sort of thing that you and I can look at very easily, but it's actually kind of difficult for a machine to do without training. So what you need to do is provide some training data. And so that's what this job did. Now, if you scale it up enough and it's cheap enough, you may not even need the machine learned model, depending on what kind of scale you're trying to operate at. So maybe you can just use the human evaluation. But either way, I would consider this steering. It's providing an input to some other process. Scoring, however, is actually measuring the quality of what might come out of your ranking algorithm or machine learned classifier or whatever. So really what we're doing is we're just taking a look at the output of some other process and then adding a score to that. So essentially you can ask people like, is this query or is this document relevant to this query? And you can roll that up into some kind of score. Metrics are going to be really, really important to scoring. So it depends on what kind of thing you're scoring. So there's, ranked lists, you're going to use a different thing than unranked content, where you might use like a % accurate or precision, recall, F-measure, preference, something like that. For a ranked list, like a search result set, you might use something like rpref, bpref, cumulative gain, discounted cumulative gain, et cetera, et cetera. So there are lots of good resources out there on what these metrics mean, what they do, how they can be used. I'm not going to go too deep into that. You can read my blog post. You can look at Ali Dazdan's slides on SlideShare there and get a really good idea of what these things mean and what they do. So I don't want to like belabor it too much. But what I will say is that choosing the right metric is going to go back to that understanding of the user, right? What is that user trying to accomplish, and what are the factors that affect it, right? So if ranking is really important, then you want a metric that is going to reflect high quality ranking. Is your user trying to find one really, really great document, like Yelp, for instance, or excuse me, not like Yelp. Maybe they want one really, really good document. I don't know. I can't think of anything off the top of my head. Yelp is kind of the opposite, right? I want as many options as possible that are good, that meet some threshold, and then I'm going to make some decision based on that. So an example of that, of how we might use that, is something like in DCG, we want to maybe have a discount function that actually more closely matches our impressions. So what we see here is that the typical DCG curve is actually much steeper and much more heavily discounted in like that 2 to 4 to 6 position than our actual impressions. So maybe what we want to do is actually tweak the discount function to more closely match the impressions, right? Log 2 of I plus 1 as a discount function really doesn't have any basis in, I won't say it doesn't have any basis in reality, but it isn't necessarily right for your application. So it's the sort of thing that you need to understand what your users are trying to do, how they actually are using the service. If you have a service like Pinterest where it's all about showing a bunch of different options and letting people engage with each of them, then you're going to have probably a much shallower discount function than something where there's like that one right document, like Wikipedia or something like that. So you need to choose those inputs wisely as well, right? So again, we're all about representing that user experience through human evaluation. So what you want to do here is you want to take a random sample, weighted random sample, stratified sample, popularity-based sample. It really depends on what you're trying to do. So I tend to focus on things like random weighted samples of queries for how I'm going to sample and seed my human evaluation tasks. Then you're going to design your task. So this is a task that we used to use at Pinterest. This was, again, a Crowdflower-based task. This is a query document pair task. So the query is 2015 spring outfits. You can see how long ago I made this particular slide. And the search result is this pin over here on the left, which is 30 cute spring outfits to try. And so, like, does that actually make sense? Is that relevant, somewhat relevant, irrelevant, or we don't know? The set of options there is actually really important as well. So I don't spend a lot of time talking about that, but in this case, we're using basically 3 options. So relevant, somewhat relevant, or irrelevant. Generally, I actually kind of like to use even numbers so that it might be like very relevant, somewhat irrelevant, very irrelevant, or something like that. That kind of forces people to choose a relevant versus irrelevant category without being binary about it. The pin unclear here is basically saying like that maybe there's just something wrong, like for whatever reason the pin doesn't load, something like that, which you know, you can run into those technical issues. You don't want that to skew your results where people are choosing irrelevant because the pin didn't load, that sort of thing. So there's a lot of nuance to creating a task. Again, this is not going to be an in-depth discussion on how to build tasks, but the next step you're going to do for your task is make instructions or mine gold. So instructions are long, right? If you actually go look at Bing search quality guidelines or Google search quality guidelines, which they started publishing, those things are hundreds of pages long. That works if you have in-house raters, right? If I'm paying people an hourly wage or a salary, I can say, hey, I want you to read this giant document before you do any rating. If you're crowdsourcing, it's probably not going to work. So what you need to do is create a set of guidelines that are pretty short, that give people the basics, and then what you can use is like gold or gold standard ratings. So these known answer ratings can provide training. So there could be a training phase of doing the task. And then there's also feedback, like when you screw something up, it's basically a teachable moment. Finally, if somebody is bad enough, you can remove them from the job if they mess enough gold. So I mentioned workers a little bit. This is important. Who are your workers? So you might have people who are in-house. You know, the quality of in-house SMEs is probably going to be really, really good. But how long is it going to take them to do a job? Like, do you have hundreds of them? Probably not. So maybe what you want are like contractors or maybe even outsourced workers from a company like Appen or so on. You might go with an experienced crowd, or maybe you're just going to go get on Amazon Mechanical Turk and you're going to throw this job open to anybody. So there are different platforms for being able to do this sort of thing. And it really depends, again, on what your task is, what your scale is looking at. If your scale is not huge, you know, spreadsheets with a few SMEs in-house is probably good. But if you need to scale up and try to use a human evaluation as a quantitative approach, then you're going to need to find ways to scale. So that could be crowdsourcing, outsourcing, contractors, so on. So just a really brief guide to getting started. You know, go scrape some search results so you can use a tool like Cupid from my friends at OSC here. Take those results, put them on AMT. I think you can even do this through Cupid. You can do some ratings through Cupid. You can go to Mechanical Turk, set up a job. It's actually really easy. You know, you have a CSV, you upload it to AMT or MTurk. And you can go find some workers, see if they do the job, see if you get quality results back, and then kind of iterate from there. So play around and see what works for you. So that's step one. Step two is online measurement. So what do I mean by online measurement? Well, I mean engagement metrics for the most part. So engagement metrics, I think, is a little bit difficult. A lot of folks who are kind of new or companies that are just getting started, you're using Google Analytics. You know, Google Analytics is great for understanding aggregate behavior. It's not going to work for search metrics. right? So what Google Analytics is doing is it's taking a sample usually, and it is reporting aggregates, not collecting every single interaction that every single user has. So to calculate engagement metrics for search, you're going to need to know unique identifiers for users, sessions, searches, documents, doc position on the SERP, interactions, what are the different things that they can do with a document. And then you're going to have to also have that scoring function and the discount function, which I'll talk about more in a sec. But before we go into that, I want to talk a little bit, an aside, about online versus offline measurement. So offline measurement of relevance can really focus on that relevance piece. As I was mentioning before, right? Those are people whose job it is for however long, maybe it's that day, that week, that year, or maybe it's that 5 minutes, whatever. Their job is to actually assess the relevance of a particular document to a particular query. And I can ask them, right, some binary thing like, is it relevant, yes or no? I can say, is it somewhat relevant? Is it mostly relevant? Is it a navigational query? So on. I can also give them some interval or ratio scale, like on a scale of 1 to 10, how relevant is this document? And then I could ask preferential questions. Is this document better than this other document? Is this result set better than this other result set? Again, this is going to be really dependent on the task that your users are doing that you're trying to emulate. So the advantage of these offline measures is the focus on relevance, right? They're captive. They're doing that particular job. They're focused on actual relevance, whereas the user has a much broader set of things that they're trying to do, right? Like they're trying to do a task, and relevance is only one piece of what gets them to engage or not engage with a document or set of documents. So the disadvantage is that it's a contrived scenario, right? Like the offline evaluator, human evaluator, crowdsourced judge, whatever you want to talk about, whatever you want to call them, they're not in the head of the searcher, right? That is not they're not trying to do the job of searching for a document or a product or get the weather or whatever it is that they are trying to, that an actual user is trying to do. The other problem is that it's based on a sample, as I mentioned previously, right? We're just taking samples of queries and then we're going and scraping our search engine based on that. So there's advantages and there's disadvantages to both of these approaches. The online measures, you might go, well, I really want to focus on online measures. Well, the reason why I actually say we should start with the offline is not that I think it's necessarily easier, but I think what you're going to get is higher bandwidth. So online measures rely on these user interactions. The problem is that users aren't focused on relevance. They're not actually sitting there looking at your 10 blue links on a page and going, which of these is necessarily the most relevant document? What they're trying to do is they're trying to accomplish a task. So users tend to be satisficers, which is to say that they find the thing that is good enough and they go for it. This is, of course, they're also likely to be distracted, not necessarily by squirrels, although maybe. What they might be getting distracted by are, the rest of their daily lives, right? Their son or daughter wanders into the room and says, Dad, I need a sandwich or whatever, right? So there's a bunch of different reasons why people might stop engaging, and that can be very difficult, right? They're not captive. We don't have them locked into actually using our product most of the time. And then we have to use interactions, and those interactions are a proxy for relevance. So clicks, we can look at how many people are clicking on a particular document for a particular query. We can look at the views over time, or views greater than time. We can use that as a relevance signal. We can look at downloads, emails, purchases, et cetera, et cetera, et cetera. Choosing those metrics is actually a really big issue in how we view our online interaction. So it used to be at eBay that what we did was we measured at one point like the number of purchases, which makes a lot of sense. However, for a query like iPod, what you would see is that the number of purchases for a $5 iPod case were like 10 or 100x the number of purchases for a $200 iPod itself. So what we ended up doing was switching to like GMB, gross merchandise bought, which is pretty typical metric for the e-commerce space these days. So the difference there is it started to actually weight the higher priced item. So that's that's a really important thing. Again, really have to understand what it is that your users are doing. And so for both of these, online and offline, we can actually turn a rating or an engagement into a score, and we just have to think about how we're going to do that, right? Is this binary, relevant, irrelevant? Are we rating these things on a 1 to 4 scale, so on? So maybe for an online metric, I'm just going to say that perhaps what we can do is if you click on a document, it's worth 1 point. If you dwell on it for greater than 30 seconds, that's 2 points. And then if you download that document or print it or email it or whatever, that's worth 3 points. So let's do a quick example. And I use the term EDCG here just to reflect that I'm talking about an engagement metric rather than a human metric, but you can actually do the exact same calculation with a human judged metric. But what I'm doing here is saying user 123, so I've got my user ID, goes to whatever my website is and performs a search. Again, I have to be able to identify that query. I had to click on a document, so I need to know that that click happened, and I need to know what position that document was in. She also clicks on the document in position 4, but then goes back to the search engine results page without further interaction on that document. So the EDCG for this is 3.93. So you can see that the ranks here, she clicked on rank 3 and rank 4, did an engagement in rank 3, but left the document in rank 4 alone. And so what our score ends up being is 3.93. User 456 comes to our website, performs another search, clicks on the document in position 1, and then she also clicks on the document in position 2 and then downloads it. So now the DCG is 5.42. So this would tell us that whatever we've done for this query is better than what we did for the previous query. So the question is that true? I don't know. You have to make that decision. Like, you have to make the call. Is a 1-3 result better than a 0-0-3-1 result? So these are really important distinctions and decisions that you're going to have to make while you're kind of building out the search program, because you need to understand what your user is doing and try to make sure that you are representing that accurately in your metrics, and that you are confident in that when you say something is better, that is actually better for your user, customer, whatever. So once you've got something like engagement metric, you can represent that over time, and you can see, am I making improvements? Are there seasonal patterns? I don't know what's going on with this particular metric here, but what I can see is it looks like it's going up over time, and it looks like there may be some seasonal variation that I need to account for. But generally speaking, it looked like it kind of went down and then things have gone back up. So whatever this metric is, looks like EDCG, I'm probably doing a decent job. Looks like I've released some stuff that's actually improved that particular metric. So moving on to step 3, which is A/B testing, right? So we can represent a metric over time. The next step with our engagement is to actually start doing some A/B testing or experimentation. To me, A/B testing is the lifeblood of a search program. It's all about our rigor, our process. We have to think like a scientist, which means having a theory, having a hypothesis, measuring the outcome, and then updating the theory of what our customers or users are actually doing. So it's not a, I wonder what this does. It's a, really, you need to have some rigor around it. So I'd mentioned kind of like taking as many swings at bat as possible, but what we really are trying to do here is not swing blindly in the dark, right? We want to kind of know what pitch is coming and be prepared for that. So as much as I hate to say it, we should be the Houston Astros, not the Red Sox, I guess. Does that resonate with everybody? Do people know about the Houston Astros having kind of squeezed their way into World Series win? So let's talk a little bit about the scientific method. I know it usually gets kind of put out there as being like a really simple thing. Oh, you make an observation and then you form a hypothesis and blah, blah, blah. It's actually a little bit more complicated than that in my estimation. And really what matters is having a theory, having a kind of like that raison d'etre. What is your customer doing on your service? And then if you understand that, that becomes the core of your theory. If you understand what your user is doing on your service, then you can have a theory of how they're using the product, and then you can create hypotheses of things that are going to help improve their user experience based on that theory. So that's kind of what I mean. I'll let you guys go through the flowchart later. It doesn't really matter for this particular thing, but it's all about having that theory, having that hypothesis, testing that hypothesis, and then updating the theory and updating your priors, if you will. If you're a Bayesian sort of person, update the priors of what you think people are doing with your website. So let's talk just a second about experiment quality. For the experiment process to work, you need to have consistent experimental guidelines. So things like duration, effect size, how much traffic are you going to expose, how are you going to measure things? Because then you need to make sure you have that instrumentation in place, as I was mentioning previously. And from there, you're going to use that instrumentation to calculate the metrics. So you really want to make sure that those metrics are the right things, which means measuring what matters. You want to make sure that you have the right metrics on the right users, the right queries, the right time frame, using the right statistics and the right testing methodologies to ensure that your outcomes are going to be generalizable to the general public of your user population. So here's kind of what I mean by that. When I'm talking about measuring the right set of users and the right kind of timeframes in search and in a lot of different aspects. So this is true of basically all experiments. Engaged users of our service tend to dominate early in the period. So this I stole from a former coworker at Pinterest. This came from Andrea's slide. So what we're seeing here is the definition of a core user is basically a weekly active user, casual user is monthly active user, and then marginal is less frequent than monthly. So what you might expect to see is that I will see basically all of my core users in a 7-day period. And that's basically what we see. Casual users, I expect to see all of them by a month then, and then marginal users, it's going to take me a lot longer to see all of them. But the thing is that the actual population of users is much more heavily weighted to the marginal user. So what we need to do is we need to ensure that we're running our experiments long enough that we can actually see a reasonable mix of core, casual, and marginal users. This is true of basically every website, service, or anything, right? Very few products have every user is a daily active user, right? That just basically doesn't exist. Even Facebook, for all of their stickiness, tend to have like daily actives and then like monthly actives, right? So this is a big point that I want to hammer home, that these kinds of users are going to use the service in different ways, and we want to make sure that we're getting an accurate sample of all of them. So we need to run the experiment for a long enough period of time. The other time effect that we often see is maybe like a learning or a boredom effect. So maybe if I have, if you search for recipes and I show everybody that searches for recipes this chocolate cake, this particular beautiful, delicious looking chocolate cake, but every time you search for recipe, this is like the first position, you might see a lot of engagement early on, but it's going to tail off. So if that was my only control versus treatment there, just showing this particular chocolate cake, you know, we're going to see that treatment effect kind of diminish over time as people are like, well, I've already seen that chocolate cake. I don't need to open that recipe again. So again, time effect, really important. So let's talk a little bit about how search A/B is different than other kinds of A/B. Multiple levels of test granularity. So we can test at this user or the session level, but we can also test at the individual query level. So we can have search specific metrics as well, like DCG, as I mentioned. And then there's a counterfactual piece, right? What would have happened had the user been in the other branch of the experiment? In UX testing, it's pretty easy, right? Did they go to page XYZ, right? Like, did they go to the home page? Did they go to the search results page? Did they view a document? If my experiment is on the document view page, all I need to know is that they saw a document and I know that they were a treated user. In search, this is a lot more difficult. So we'll talk a bit about that in just a second. One thing that's interesting about search is that if we test at the query level, we're going to have a massively higher N What I mean by that is that the number of experimental trials, if you like, is massively increased because I just get more searches than I have users, unless for whatever reason I have one search per user, then which would be kind of weird, but possible. In this case, as long as there are more searches per user than one, I'm going to have a much higher N than I would if I just test at the user level. So that kind of creates this sort of within subject metric piece that we can do, which is going to give us a lot more statistical power. I can look at what one individual user did over time and see, does that behavior change over time? So kind of like the inverse of my cake example here is that, well, or just using this cake example, I can kind of see what does that behavior look like for an individual user over time, and then I can aggregate that behavior to kind of come up with what is the aggregate effect of this particular treatment. Which is, you can do that to some extent with user or session level testing, but with queries, you just get a lot more of it. And so as people are learning what they can do with the system, you might get a difference in behavior, right? So my green line here kind of shows that over time it started out poorly, but in the end, it ends up being a winning treatment. So let's talk a little bit about the counterfactual. So again, what I mean by counterfactual is what would have happened had the user been in the other branch of the treatment. And again, I have to say I stole these slides from my friend Andrea. So you should definitely, Andrea Burbank is her name. You should definitely go do a quick search for Andrea Burbank QCon. So dilution is kind of the opposite, right? So let's say I have two types of query, natural language and Boolean queries. And if what I've got are, I've divided up my users and I've put half of them in treatment and half of them in control. And then I measure how many of them are actually happy users. I can see my happy little users here. And it looks like I actually come up with about the same number of happy little users in each group. But then if I actually take a look at which users did a natural language query versus which users did a Boolean query, again, about the same number, but that distribution looks different. And so if I look at the overlap of which users are happy in control and which users are happy in treatment that have actually done a natural language query, I can see that I was diluting the effect by just looking at the overall effect. I really needed to look only at users who had done a natural language query. So that's kind of dilution. To understand the impact of this particular search algorithm, I have to have some counterfactual. I have to know what would have happened had the user been in the other branch of the experiment. So I need to know which exact type of query was affected by this algorithm and focus only on those particular queries. So there's a few different ways you can do that. You can rerun queries, offline, that kind of stuff. What we do at LexisNexis is we actually have what's called this handled flag. And the handled flag essentially kind of drills down the query plan and shows if something would have been affected or not. So the takeaway is that search is like any other kind of A/B testing, except the granularity is different, the metrics are different, counterfactual logging is different. So it's really actually pretty different. So what's the next step? How do we know, did we get where we were trying to go with our search algorithm updates? Well, to know that, we're going to use something called the launch review. So launch review is bringing all of that stuff together. So we have an experiment. In that experiment, we're going to get offline data, we're going to get human evaluation, we're going to get A/B test data, and we're going to put all of that into a document, have a meeting with key stakeholders, and actually make a decision. So that's the purpose of the launch review. The key artifact here is the launch review doc. It is the thing that acts as kind of the repository of all that test data. So we're going to put in the human evaluation stuff. We're going to put in our scrape metrics. We're going to make sure we've got our theory of the game, and we're going to make sure that we have our hypothesis and all of that fun stuff. Make sure that that is in a document. We're going to have all of our metrics in there, and we're going to put in our takeaways. So not just metrics went up or down, but also like, what does that tell us? What are the insights that we gained from this so that we can, again, update that theory, right? I'm all about having a theory. So that's the extraction of insights piece. I want to actually extract the insights and use that to create new tests further down the road. This meeting, the launch review meeting, is our chance to make a case to the other engineers, product managers, team leads, whatever. It's our forum to kind of talk about what it is that we learned. So that's our opportunity to get everyone on the same page, and it gives other people the chance to ask questions. So one of the things about a launch review meeting is that somebody has to act as the actual decision maker. That's really going to depend on the organization. Maybe it's the search product manager, or maybe the search product manager is the person who's actually presenting that information to the higher ups, maybe your director of engineering. I don't know. It really depends on the organization. Ideally, everybody should be on the same page, but what should be, I think, important though, is that somebody in there is the final decision maker and is going to make a go, no-go decision. I think that's just really critical. Too often, I think we end up in meetings in the corporate world where there isn't a clear decision maker, and it can be problematic because you kind of end up with no real decision. That's not great. We want to have a real crisp decision here. Yes, no, or go back to the drawing board. All right, so where do these ideas come from, right? Where are we actually getting these ideas that feed into experiments? Well, one place they can come from is this query triage. Query triage is going to kind of tell us, where do we go next? So if that launch review is all about, did we get where we were trying to go? The query triage is trying to figure out, okay, what is the next direction that we're going to take? So query triage is how we're going to work to continually improve. So first, we need to find some bad queries. I like to call them good bad queries. So we need to find queries that are exemplars of classes of query that we do a poor job. So we can use A/B test results. We can use human evaluation. We can have surveys. I know a lot of companies do NPS surveys. We can use UX research. We can use market research. Whatever we have, we can kind of throw that in the hopper, right? Even our own anecdotes, or my favorite, the hippo, right? I was doing a search the other day when you know, I noticed that the search results were not exactly what I expected. So oftentimes we want to discount the hippo. That's the highest paid person's opinion, by the way. But in this case, we can throw that into the hopper, and we can actually try to see if that is maybe a query that's an exemplar of some sort of class of query that we do poorly. So what we need to do is find these bad queries, figure out how big a deal are they, right? How many different queries are in this set? And how badly does this screw up the user experience, right? Then we might want to figure out how hard is it for us to fix this, and with that, we can prioritize it. So how serious is this issue? How many queries are affected? And how difficult is it to fix? That's going to tell us our priority. So query triage is about having all of those people together in one room. So, you know, we want to have the engineers, we want to have the product managers, we want to have UXR. UXR is UX research, by the way. Maybe our marketing people, whoever, right? We want to have the stakeholders in the room, because there's a kind of technology push piece, and then there's the user need pull. So what I mean by that is that oftentimes I think we really get very excited about technology in the search space. Oh, there's this fancy new, you know, embeddings model. Oh, well, we've got BERT. Oh, there's, you know, GPT-2, whatever, right? Like all of these fun, exciting technology things that we can do. And then we've also got a lot of times, like we know that, I don't know, we do a poor job with natural language queries that have a person's name in them, something like that, right? What we need to be able to do is marry those two things together and try to find what is going to be the overall impact, right? There's no point, like I say, swinging in the dark with, hey, I've got this technology, whack, 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 right? I'm going to just like use technology to swat around blindly. what you really want to do is marry the technology to the user needs. This technology is going to help me solve X user problem. That's how you have to think about it. Or I have X user problem, what technology can solve it? So an example of that was when I was at eBay, we had this thing with parts of appliances would be ranked more highly than the appliances themselves. So you'd go in the appliance category and you'd search for refrigerator, and you'd get a bunch of refrigerator compressors or, you know, ice trays or whatever, right? Like parts and accessories. The thing that is obvious about that is that actual refrigerators tend to be a lot more expensive than the parts and accessories. So there's a couple of approaches you could take. You could break out the segment or the category. The approach that we ended up taking was one that like focused on finding the right price range for things. So to do that, we did some machine learning. The key insight though kind of came from the business unit. So our business folks in the UK, you know, basically said, hey, wouldn't it be good if we found like the right price for a particular category, and we, you know, boosted things that were in that particular price range. So we had to do some machine learning and find what was that right price per category. So that's exactly what I mean, right? There's some technology push. We have some machine learning. We can train a model based on that. But the user need there and the insight was we're showing the wrong kind of stuff when people are searching for refrigerators. So user need pull, technology push, bringing the two together is really what's going to drive improvement. So who is doing all of this stuff? Well, you have to have a team, right? I mentioned engineers, but there's going to be other folks on the team as well. So that's why it's step 0. It's the sort of thing you should kind of do first, but at the same time, that may be the most difficult thing to do is actually building up the team. So it's one of the reasons why I left it till almost last. It's just such an important thing. Kind of determines everything else that you do. So who makes up your search team? Well, there are different roles. So you can have search engineers, data scientists, UX researchers, product managers, and they can map onto different kind of sub teams. So backend and indexing, recall, expansion, ranking, front end, so on. There are different parts of that search experience. There are different parts of the search engine. So oftentimes you kind of have like one overall search team, but not always. Depends on the organization, depends on your maturity, depends on how many people you have. But these are the kinds of things that people end up doing, right? So maybe they're explicitly a sub-team and maybe they're not. So each of these groups kind of has to work in harmony. Each of these things has to work together. So the backend and indexing is basically getting documents into and out of the index, right? So LexisNexis, we have a loader team, right? Their job is to load documents into the place where they can be indexed. We're getting new documents every single day, like millions and millions of documents every day. So I don't know how many billions of documents we have in our repository these days, but it's a lot. Their job is also going to be optimizing the index performance. So how fast can we index documents? So our friends at OSC are going to know a lot about that because they've been working with our team to work on improving indices, whatever. Recall and expansion. So recall and expansion means that we're trying to bring back the most relevant documents. So just bringing back in that result set the stuff that is most relevant to what the user wants. So we might have things like spelling, synonyms, stemming, all of those different regularizations that we might apply to the query, we might apply to the index or the documents. So all of those things, and we might want to figure out do we want to do that in stemming and regularization? Do you want to do that on the index side? Do you want to do that on the query side? Each has their advantages and disadvantages. You might want to do something like category mapping, like I just mentioned, right? We want to be able to map. If somebody types in refrigerator, they probably are searching within that home appliances section, right? So if I go to homedepot.com and I type in fridge, what I need to do is map fridge to refrigerator, and I need to map refrigerator to the appliances category subsection refrigerators. And then it's going to show me what I need to see. Again, knowing what your customer is trying to do, really important. The ranking team, I think, we think a lot about ranking in the search space, but it is one part of it, right? It's taking that list of documents that is coming back from the index after all those recall and expansions. And we're going to try to put the very best documents at the top. So this is where we're going to, learn to rank, machine learn ranking, all those other TLAs. I know that like BERT is not a TLA, but whatever, there's a bunch of different acronyms that we can use to help optimize our ranking function. But again, that's just one piece of the whole pie. And then front end, right? This is the bit the user actually sees, the big red search box at LexisNexis, which is no longer that big or that red, but that's how it is. That's what we call it. Google, right? So, very, very simple user experience. Kind of. It's gotten a lot more complex over the years. Good UX is going to cover a lot of sins, right? If you have a really easy to traverse category tree, then you don't have to worry quite so much about the category mapping of queries to categories. But it's not going to fix everything, right? So these things have to work together. If you think about spelling correction, if I just go around randomly correcting everybody's bad spelling, they might get pissed off in some occasions because they intentionally misspelled something. Or this was a favorite at eBay, list of intentionally misspell things, because then you could find stuff where the seller had intentionally misspelled stuff, and therefore the product would be a lot cheaper because it would get a lot fewer eyeballs. So pro tip, that doesn't work so well anymore because spelling correction has improved so much. But you need to tell people that you're doing that, right? You need to tell them that you've actually corrected that spelling so that they can back out of it if they want. So who makes up the search team? Well, you need to have a mix of different skills on the search team that are going to kind of match to the different tasks or different subgroups that are available. So you need to have search engineers. So engineers that are going to work on indexing, optimizing, ranking, recall, machine learning, all of those different pieces. You need engineers to work on that stuff. You need data scientists to measure, to run the experiments, to do the data mining that are maybe going to seed some ideas, to look for things like opportunity sizing and try to figure out how many queries fit into this classification, right? Sometimes search engineers and data scientists are the same people. Depends on, again, it depends on the team. But I'm going to break them out as separate here for reasons. UX researchers, so connecting to users, finding those different use cases, trying to understand how painful is this particular problem. And then product managers are going to be the people that bring it all together, do the prioritization, do that communication, connecting people to the outside world. Which I think is actually kind of bears a note and aside all its own, which is the search product manager is maybe a bit misunderstood as a role. So, product managers overall, I think they have to do a lot of things like prioritizing, planning, communicating, connecting team to customers, users, stakeholders, upper level management, so on and so forth, right? To me, the product manager is the hub of this many spoked wheel that is whatever the product team or feature team is. So it's a really critical role. However, what's different about a search PM is that they really have to understand information retrieval. They have to understand how people go about searching. So Pete Paroli has this good model. It's like, it's called Sniff Act. It's basically like, how do people search for information, follows this kind of foraging model of how animals forage for food. So I think it's a really fun way to think about things. Like it's sort of like if you were wandering around looking for mushrooms in the forest, is how people wander around the web looking for information. You have to understand recall, ranking, expansions. Like what do each of these things do? When do you apply them? How do you apply them? What is the best place to apply them? You have to understand all of that kind of stuff. You have to at least understand some basic machine learning techniques. I don't think that one has to be a machine learning expert to be a good product manager. You have machine learning experts on the team. They're called engineers, right? So let them do the machine learning. What I think really matters is that the product manager is going to understand where things are likely, what things are most likely to be successful. And again, matching that technology push to the user need pull, right? Technology for technology's sake isn't going to help you any. You also have to understand metrics and A/B testing, right? So you're going to have to understand how is MAP different than DCG and what happens differently if I optimize for MRR versus MAP versus DCG versus some other metric that hasn't been invented yet. So what are the things that you're trying to optimize for, and how are you measuring that optimization? So that's a really critical role of the product manager. Now, some places actually are going to have the search product manager do the implementation of the algo. So this is true in a lot of places where it's kind of human tuned. So many places, what actually happens is that there are machine learning things and that feed into a final human tuned algorithm that might have like 5% MLR, 5% LTR boost, 3%, Boolean, like, I don't know, right? There could be a ton of different things. So just to say, like, there are different levers and things like that. And a lot of times those are really hand tuned, and the machine learning can just be one of those levers, or it can be something that sits on top. Really depends on the structure of your org and the structure of your search engine. But a lot of times product managers may be the people who actually are responsible for finally kind of doing that final tuning in A/B testing. So just pointing that out, that so search product manager, I think oft misunderstood role, very important one. And, so that's all I'll say about that. Bit of a bird of a different feather. Okay. Step infinity. How do we bring all this together? Why is it step infinity? Because it's the song that never ends, right? It's the thing that we're kind of going to always be doing. So where do those good ideas come from? I asked the question earlier. I will now answer it. Good ideas come from everywhere, right? So we have that technology push, the user need pull. We have anecdotes, surveys, metrics, hippos, and so on, right? We have all of these different sources of data. Somebody's going to turn that into information, and we need to figure out where what our best chances for success are. Good ideas can come from anyone, right? It can come from engineers, can come from data science, can come from user experience, can come from the CEO, can come from anybody. The best ideas are going to come when multiple disciplines come together with a close eye on solving those user problems. Again, firmly believe in that user pull technology push model where we're matching those two things together. And again, you have to understand what it is your users are doing. So you need to figure out a process that's going to work for your team and your organization. So build that process around collecting the ideas, quantifying the impact, and prioritizing what's going to deliver the most value for the least effort. So here's an example process, if you like, right? We'll start with an idea. We're going to go off and get our offline metrics through scrapes, figure out, what's kind of the average online DCG for this or whatever. Then we're going to do some human evaluation. We're going to see like what's relevant, what's irrelevant. Does the number of relevant queries go up? Does it go down? Does it go sideways? Whatever. Then we're going to, if we get through our human eval, we've decided that, hey, our relevance has improved. Now we're going to go into A/B testing. In A/B testing, we're going to see, does our engagement improve? Then we're going to have that launch review. So in the launch review, we're going to look at that launch review doc, which has been getting updated ever since the idea phase. So that idea phase, the launch review doc, what we're going to put in there, we're going to put a hypothesis. We're going to put the theory of the case, like why are we doing this thing? What do we think is going to be improved? How are we going to measure that we haven't made that improvement? So that feeds into the rest of the cycle. So we get to the A/B test, we do the launch review. Now we're going to look at those offline metrics, the human evaluation metrics, as well as the online engagement metrics, and understand, like, is this good? Is this bad? For what kind of queries are we seeing improvement? For what kind of queries are we seeing regression? So this is where we're going to have that segmentation around users, a segmentation around queries, and it's going to allow us to deep dive. Hey, it's really interesting. We saw Boolean queries are doing more poorly with this A/B test. Let's go look at the human evaluation. Oh, the raters are saying that they felt like we're not ranking Boolean queries properly because of X, Y, or Z reason, right? Here's some examples where we're not doing a great job. And so we can use that qualitative information to update the quantitative, use all of that to make a decision on whether or not we're going to launch something. Over time, we're going to have these query triages, and we're going to have all of these different ideas. So we're going to feed all of those different ideas that you see in the middle into the query triage and try to match what is our low-hanging fruit. Like, what's going to have the most impact? What's going to affect the biggest number of users? What's going to affect the biggest number of queries? What are the biggest problems? So we're going to use all of these different kinds of information. And from the query triage, we're going to have a new idea. And we're going to prioritize that appropriately. And then the cycle starts all over again. So how are we making sure that we're making improvements, right? So we're going to use that qual and that quant to understand the what and the why. So in A/B testing, we're going to look at engagement going up or down, which are the metrics that changed, right? Did DCG go up and MRR went down? What that tells us is maybe we're getting more engagement, like we're engaging with on average 3 documents per result set instead of just 1 document per result set. But that overall engagement is slightly lower down the rank ordered list of results. Like just being able to decompose that kind of thing. What segments, right? So we're going to have different user segments. Who are our power users? Who are our latent users or whatever? It's going to have that scale, right? So engagement, we can actually scale up. We can look across a ton of different users, but fundamentally it's engagement. It's not relevance. Human evaluation is going to tell us, did our relevance change? Which metrics are we using to measure that relevance? What query types are we using? Did we see consistent issues? Is it all of our Boolean queries were lower, but all of our natural language queries went up? Okay, maybe we want to ship that in the end. So this is going to give us that deeper dive, that qualitative insight. Importantly, right, understand what the data are telling you, understand how they change, use all those different sources of data, figure out like are we seeing engagement metrics different than human evaluation metrics? Are we seeing different engagement metrics change differently? So we need to understand all of those things. So use that query triage to find the areas that you can exploit, find that low-hanging fruit, and then go after it, right? So what are we optimizing for? That's up to you, right? Like, do we want to optimize for DCG? Do we want to optimize for MRR? Really depends on what your user's task is and how you want to try to best answer that task. So in conclusion, you need to build a great team with a diverse set of skills and experience. You want to start with human evaluation. That higher bandwidth information is really going to help you get started. You want to measure all of your things, like measure everything, right? You want to measure all those clicks, dwells, scrolls, all that jazz. A/B test your changes using the metrics based on those deeper levels of engagement. Use launch reviews to help you decide if an experiment is worth launching. Query triage is going to help you find problems and figure out how to solve those problems because you've got everybody in the room. You want to collect ideas and take as many shots as you can to solve them, right? So it's all about the at-bats. Take as many swings as you can, and then maybe, hopefully one of these will be a grand slam. And that, dear friends, is it. So, check out, check me out on Medium or hit me up on LinkedIn, do all that good stuff. A couple of things that you can reference and read. Try to throw a couple more things on there, but I ran out of time. But check those out. There's definitely some good stuff out there about search teams, about search metrics. So I don't want to pretend to be the be all and end all expert here.
James, thank you so much. That's fantastic.
Yeah. Okay, I've got a couple of questions in the chat.
Sure, let's just have a look.
Yeah, let's see here.
Okay, so let's see. I think we have from Bruno. Bruno wants to know, you mentioned user identity, but can you say a little bit more about privacy related to user behavior analysis and how you manage it?
So the requirement of the law is, as I understand it, not that we are not able to identify a user, it's that we can't identify a user and map that back to an individual. So what I mean by that is you can have user ID 1234. It's just that it's considered PII if I try to map user ID 1234 to Charlie Hull or to James Rubinstein or whatever, right? So that's generally considered okay. that if you have anonymized usage statistics, those are considered okay.
Okay. So I think that's the only question I can see in the channel. So
okay. I have one from Helen. So okay. Helen Souza asked, can you explain what you consider a Boolean query and a natural language query? That's a great question. So Helen, back in the olden days of searches, you had to use Boolean operators. What that means is like, you would say, if we were searching on Lexis Advanced, for instance, I would have to type dog and bite or dog or bite if I wanted either of those words. So I might have a query that looks like dog or canine or animal or pet and bite and liability. So if that expression would mean that anything that matches dog, bite, and liability is going to match, but also canine, bite, and liability also match. So a Boolean are just sets of operators that define what's in and what's out. So and or not is Boolean logic. The alternative is natural language, where I would go into Google and I say, what is the weather in Raleigh, North Carolina today? And Google knows what I mean and shows me that it's sunny and 72 or something. I don't know. I haven't been outside. Does that answer your question?
Does that answer your question, Helen?
Yeah, she said, cool, thanks. Okay, yes.
Excellent.
What other questions? I know that this is an inquisitive bunch, so I'm sure.
Okay, so do we have any more questions for James? Do type them in the chat, or actually we've got a reasonably small crowd. If you would like to unmute yourself and ask it, please feel free.
Okay, I've got one quickly. You use the acronym HDCG.
Yep.
Is that distinct from NDCG?
No, sorry. H just means human in this case. So human rated DCG as opposed to engagement based DCG. So just want to, I just try to like clarify those because you can use the same scoring function. You can use the same discount function, but where they're coming from is different. So I just wanted to like make a distinction between those two things. So my dear friend Doug Rosenoff, who y'all might know, kind of came up with that particular acronym. So it may be specific to LexisNexis that we do that, but I like it. It makes sense. N refers to a normalization, which is just like normalizing over an optimal ranking set.
Yeah, that makes sense. Thank you.
Okay. We had another question in the channel. Alex asks, would you recommend any disambiguation approaches?
What do we mean by disambiguation, Alex? Are we talking about query disambiguation where, so for instance, my favorite example is of a ambiguous query would be like stiletto. Is that what you're talking about? Where you might mean shoe and you might mean knife, or you might mean movie, or you might mean a hammer.
Alex, do unmute yourself and ask.
Okay. Well. Let's see. Channel for programming an actual bridge. Yes, that is a good question. Okay, so yes, you do mean an ambiguous query and trying to disambiguate the query. There are a few approaches to that. So stiletto is my favorite example because it can mean a couple, 3 or 4 very different things. So shoes or knives. Yeah, no worries, Alex. So if what I'm talking about is, so there's a couple of different approaches. One is a more conversational approach, which might be like, I type in stiletto into Amazon. And what it might ask is, did you mean shoes? Did you mean knives? Right? And then maybe it doesn't give me any results, or maybe it does give me some results. Another way that you can approach this is with something where you might have diversity enforced in the query, where even if shoes are the most popular, it may actually enforce some number of knives getting into the result set. So it might go shoe, knife, shoe, knife, shoe, knife, shoe, knife. The way that it actually works at the moment is because there's actually more stuff called stilettos these days than just shoes and knives. It'll actually show me tools, like there's stiletto hammers, but it will also show me stiletto heels, a movie called Stiletto, and a book called Stiletto, and so on. So that's their approach, is to generally enforce diversity. So Another approach might be you just go with what's popular and give more people that. So I think that's an okay approach. But like, so maybe the bridge, the program on channel 4 is really, really popular at the moment. So that's probably what I mean by the bridge. You could recognize it as an entity in that particular case, right? But if I just type in bridge, I could mean Brooklyn Bridge. I could mean the Newcastle Brown Bridge. I could mean the TV show The Bridge. I could mean a bunch of Phoebe Waller bridges. I don't know, right? There's a bunch of things that could fit that. So you're going to try to disambiguate that through diversity or through a conversational approach. Okay. Oh, I've got lots of them coming in now.
Yeah, Donald, I think, is next with, have you had any success in A/B testing by interleaving?
Oh, yeah. So I didn't mention interleaving because those slides kind of ended up getting left on the cutting room floor. Yes, interleaving is a really cool approach to search A/B testing. For those not in the know, what interleaving does is it takes like ranker A and ranker B. Hopefully my hands don't get chopped off here. And it basically says, I'm going to take the results from A and B and put them together, and I'll go A, B, A, B, A, B, A, B. And then when people engage with A gets a little credit. And then somebody else is going to see B, A, B, A, B, A, B, A, B, A. And when B gets interacted with, B gets a little credit, right? So generally you're looking not only just within subjects, within an individual, but within the same query so that intention is exactly the same. So it's a super powerful, statistically speaking, a very powerful methodology, and is really, really good for search A/B. But yeah, I kind of didn't want to derail the talk. The infrastructure required for it is a bit different because you have to have like these re-rankers that can actually take two different ranking sets and stick them together. And then you also have to have a different like interaction model, I guess, to do the scoring differently. So you're not just going to be using a straight DCG model. You're going to have to be kind of calculating this preference score based on interaction and position. So there are some really good papers about that. Is it Redlinsky? I think it's Redlinsky that you should read if you have interest in that. But yes, it works. It's great. It's what Netflix does. It's also what several other search engines do. For a time we were doing that at Pinterest. I don't know if they still do.
Okay. Shreyas has a question about how deep a PM should go into the technology to get relevant results and improve customer engagement.
So what I would optimize for, Shreyas, is definitely have the good PM skills, right? So you definitely want to be really good at the discovery, the connecting the team to the customer, connecting the team to the customer, problem, prioritization, communication, all of that normal PM stuff that everybody should be good at as a product manager. Where I think what you're asking is how deep to go technically, and the challenge there is it really depends on the organization, right? It might be that you just don't have that technical depth in your data science group, or you don't have that depth in your search engineering group. So you may have to pick up more of that technical capability. So you might have to really more deeply understand machine learning techniques, or you might have to really more deeply understand things like interleave testing or whatever. So it really depends. I know it's such a crap data science-y answer, right? The answer is always it depends, but it really does depend on your organization. My approach would be that you should know enough to be dangerous. You should know enough to walk into a room of engineers and be able to say, but what about? And they might think that that's a bad idea, but at least you can kind of like bounce the ideas around. So knowing enough to be dangerous is usually my goal as a search product manager. That I should definitely be the person who knows the most about what our users are doing, why, and what are the likely impacts of a change that we're making.
I'll add to that. I mean, I think we've actually done specific product PM training at OSC. We did it for the e-commerce PMs at, I think it was at a Mises conference a couple of years ago. And it seemed to go down pretty well. We haven't done it many times, but there are lots of resources out there for learning more about search. I certainly get them, joining relevant Slack and asking lots of questions in there, and
Yeah.
reading lots of the books that are available. Getting a copy of Relevant Search.
Yeah.
But I'd
Love
agree with
that.
James. I think it depends very much on the organization. You want to know enough, but and maybe a little too much to ask those awkward questions of the tech people.
Yeah.
Our next question comes from Suzanne. How would you A/B test 2 different Solr configurations?
That's probably a better question for Charlie, actually. So yes, you can do it. It definitely can be done. We have done it before at various places that I've worked that use Solr. So you can test query parsers. Again, what you're going to be looking for are a lot of those metrics around engagement, that sort of thing. Charlie, you may know better than me, so I might just open it, let you answer that.
Yeah, I'm just going to. I mean, if you want your, some of your users seeing one Solr, another seeing another Solr, then you're either going to have 2 completely separate Solr configurations, Solr instances set up, or you can do it by effectively having different query parsers that do different things. It's going to depend how you split the problem up. I mean, if you've got 2 completely different indexes, you need to be querying both. So it's another, it depends, I'm afraid. It's certainly possible. You've got to remember that the innocent view of a Solr search engine is you type in some stuff and that's the only thing that queries Solr, but actually lots of queries can happen behind the scenes on the actual engine to answer that user query with the type stuff into a box and click go. So there's many different ways to wire this. I think you'd have to write some code on your UI layer effectively to manage this and talk to those different endpoints. But there's no theoretical reason why you couldn't do it.
Yeah. And the other approach that you can take is to test at the user level, which is to say that maybe I get stack A and you get stack B. And every time I come back to the site, I get stack A and you get stack B, right? Like that's an approach that requires replicating your entire stack and then just changing a piece of it. So that's one way to do it. And then you can potentially have in your code base kind of directing different pieces to A versus B. So you can have like different parsers, and you can have different indices or different index structures.
I'll add a little bit about offline testing. The rated ranking evaluator tool, which I'm a great fan of, effectively when it runs a test, it spins up entirely new instances of the search engine. So you could have it do this for you quite easily, or that's more in the offline context. So we've got time for one more question. Shreyas asks, which metrics did you track for search on Pinterest? The question's in the context of metrics for marketplace versus e-commerce site.
Usual stuff, DCG. And again, we'd have a scoring function specific to Pinterest. The overall goal being to try to increase repinning. So that's one of the things that we really focused on was how can we drive more repin behavior. So I'll leave it at that. Oh, well, there's one more. Oh, if we have time.
Yeah, we can squeeze this one in. The UX job on search.
Yes. Supporting designer in the search team, I'd like to know. Okay. How to bring million. Yes. Okay. Honestly, I think that this is a really important piece. I think UX often gets short shrift when it comes to search because we view it as a very technical thing and there's a search box and we bring back documents and UX is just not important. That is not true. UX is such an incredibly important piece. So design is important, but UX research and understanding the task of the user, the jobs to be done methodology is one that we like. There's a bunch of other ones, but just really deeply understanding what users are trying to do is so critical. So bringing problems to the team, I think can be useful. Like here is a specific issue. And because people think in anecdotes, so you can bring data all day, but it tends to be that bringing an anecdote to them to like demonstrate where the problem is going to be even more powerful and get them invested in making some kind of change. And then as a designer, I think it's really important to understand like what does the workflow look like? you know, what are people trying to do? When are they trying to do it? How are they trying to do it? And finding places where there might be problems that can be best addressed through UX rather than by, you know, improving ranking or relevance. There's always places where that can be done.
I'd add, get this book if you haven't got it already. Tony Russell Rose is excellent. This is kind of the reference text on Search UX. There's a website as well. I'm dropping into the chat here. I will say that I actually talked to Tony last week, and he says that, you know, there's a dearth of search people who understand UX, and also there's a dearth of UX people who understand the particular constraints of search, because it's not just, you know, I mean, search user experience is a special kind of user experience as well. So there's definitely room for more work in this area. And I think it's absolutely essential. The last question I'm going to say here, Florian asks about investing in LTR early on when developing a new search solution. Should it be done even before all the stemming and ...
So there is a school of thought that is essentially we can throw machine learning and the machines will figure it all out. And then there is another school of thought that is much more, I guess, like user focused. And you can do both. If you have limited resources, I would actually focus on understanding and tweaking the levers manually, because it's just going to help you understand more than throwing something through the black box of LTR. That's my personal opinion. Other people have different opinions, so I don't want to get myself in trouble, but I would suggest actually kind of going down the manual and hand tuning route first, with LTR in your back pocket, because there's still a lot. LTR can only do so much, would be my take.
I would add that I think I've seen people invest in LTR possibly too early, and until, you know, you really understand your data, your signals well, and you know it's high quality, you don't really have the resources for tuning an LTR model. So I think you have to be very careful in jumping into them, especially if it's the nice shiny thing, and promises much, but I've also seen people waste a lot of money before they were very ready for it. So I'd tread carefully with that. James, I'd like to thank you very much on behalf of everyone for your talk today. That was fantastic. We have got, we will be videoing the talk, obviously, and that will be up on our YouTube channel soon. So do pass it about to colleagues. We do have a future talk coming up. I'm just going to show you this slide, if I can get this to work. So if everyone can see that, do join relevant Slack, share the videos around, join the meetup, encourage your colleagues and friends to join as well. We have got upcoming events on our Open Source Connections website, various talks we're giving at various places. Our next talk is going to be October the 22nd from Tim Allison on duplicate and near duplicate detection at scale. Tim's always a great speaker, so looking forward to that one. And again, just to mention our forthcoming training, if you do want to do Learning to Rank, check out the training happening next week, and the natural language search training happening later in November. And we'll see you back on Haystack Live on October the 22nd. Thanks again, James, and thanks everyone for coming.
Hey, thanks for having me, Charlie, and thanks everybody for attending. Cheers.
Okay, bye everyone.